Hi everyone, welcome back to Art of the Part. In this video, we're going to continue on with the Ye Olde Pop Topper case study. And in the last video, we left off by importing, scaling, and moving DWG and DXF files. And we positioned our reference geometry here down and to the left of the origin because that's going to make it easier for us to actually program or write G-code to. Likewise, when we're doing this in 5-axis, we're actually going to rotate the part along this top face and we're going to engrave our name because that's what we see here on the blueprint here. If I zoom out, it says engrave name right there. And if I have my origin set to this top face, it's just going to make that process a little bit easier. So what I'm going to do is I'm going to show you a couple ways that we can process the DXF or process this geometry. I'm going to show you like a bad practice way, and then I'm going to show you how I would approach this in creating new geometry for a 3D file. So the first thing that I want to do is I actually want to exit out of the sketch. We know that we're in the sketch because we see that the sketch color is blue. So if I go ahead and hit exit sketch, it'll turn gray. And I'm going to rename the sketch geometry here in the feature tree. So if I click once on the only feature here, it should be model. If I click once and I click again, I should get the ability to rename this. And I'm going to just name this reference sketch. Likewise, if I'm having trouble renaming it from that, I can also right-click it and I can hit the drop-down menu and go to feature properties, and I can rename it that way as well. And then I'm going to then make this sketch a different color because it'll be helpful for when I toggle it on and off, almost like using it like a sheet of tracing paper when I go ahead and create my 3D geometry. So I'm going to right-click on the reference sketch, go to sketch color, and then I can choose any color that I want. I'll make it red. Just makes it a little bit easier for me. Okay. So I'm going to show you again like a bad example. So why don't you just follow along and just take in what I'm going to explain here, and then I'll start up again and show you how I would process this or what I would call good practice. So if I start a sketch here on the front plane, I can go ahead and start picking some of this geometry. Now DXFs and DWGs are a little bit tricky because we don't know if everything is completely tangent. There might be some rounding errors like I was talking about in the last video from when it got imported, maybe from like an earlier software. And we can see that by right-clicking on one of these lines. And I should see the option to either select by loop or select by tangency. And I'm actually not seeing either of those options. So that's telling me that there's a break somewhere along the line of this geometry. Likewise, as long as I'm in a sketch, I can go to convert entities, and I can choose like this top edge here, and as long as I have select chain, it should attempt to try to grab everything that's in a loop or that's tangent. And when I hit the green check mark, we'll notice that it does not go anywhere but that single line. So that's telling me that somewhere along this sketch here, there is a break that is not being registered as tangent. So I'm also going to show you one thing here. If you wanted to process this very quickly and you just needed to get like the volume or the surface area or the weight, you could always just go in here to convert entities, grab every one of these lines. This is kind of annoying because you'll have to do this, line by line. Oops. And it takes a little bit of time. And you can imagine with the more complex the file is, the more time that this would take. So if everything is fully tangent, it's a little bit more helpful. But if I hit the green check mark and I go to features, extrude boss base, and I get the value of 0.46 because that's what I see on the case study, I have it tied to that geometry. The problem here lies in if I ever get a revision change that needs to happen, say maybe this arc needs to be updated. If I go into its reference geometry, well, it's contoured or it's converted from the original DXF, which means that I can't actually change that dimension. And then if I go in here in the reference dimension, we'll notice that all of this is underdefined. So if I try to change this and I try to associate some, dimension to it, it might start changing the geometry around the part as well. So that's not really a good thing. We don't really want to see that. So I'm going to end up getting in trouble here if I try to make some of these changes from the DXF file unless it's fully defined. So what I'm going to do, I'll actually show you one thing here. If I delete the reference sketch and it's all built off of that import, I've seen it where, DXFs either have to be, swapped out, or maybe the, DXF gets corrupted and I have to re-import it. If everything is tied to that, well, it's going to actually create an error. So it's going to have geometry that is unbound and unlinked. And I'll end up having to delete all of this and reassociate it again. So I'll just undo that. I'm going to delete that and then delete this geometry. And we're going to start here from what I believe is best practice, and that is to separate the DXF import from the geometry that we're eventually going to create here in the 3D space. So I want everyone to get used to toggling between turning a sketch on and turning it off, which is done by using the hide and show command. So if I right click on the reference sketch, I can choose to hide it, and that turns that sketch off. I can also right click it and show it, and it turns it back on. And that's just that little eyeball icon. It's like the closest one, essentially the bottom left inside of this toolbar when you hit the right click. So off, on. I'm going to turn it off really quick and start a sketch here on the front plane. And I'm going to start off by drawing a circle down and to the left of the origin. And I know that this value is going to be 0.4375. I could reference the sketch or the blueprint here, and I know that it says R.219. If I doubled that, that's going to be 0.4375. And I know that it's going to be down and to the left a value of 0.21875, which is what we used in that offset, the move commands in X and Y. So I'll smart dimension this. I'm going to make this 0.4375. I'm going to smart dimension it from the origin here. I'm going to make that 0.21875 in Y, and then I'll make it 0.21875 in X. So all that essentially did is it lined it up to where we offset that geometry with the move command from the DXF. And if I wanted to check against that and make sure that I'm in the right location, I could go ahead and exit that sketch, and I can turn on my reference sketch. So I can turn it on and see that, hey, I'm exactly where I want to be. And while this is on, I want to reference this in such a way that I know what geometry I'm going to create next. So I'm going to probably draw a line that's horizontal to the left. Then I'm going to create an arc, another arc, another arc, a straight line, an arc, 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 and then an angled line, arc into a straight line, and then into an arc. Now I'm actually going to make this arc here and this arc here 2 intersection points, and I'll fill them in with a sketch fillet later because I think it'll be a little bit easier for us to process. So now that I kind of have a good idea of how I want this geometry to lay out, I'm going to turn my reference sketch off, and I'm going to start creating geometry from that other sketch that I had. So this next sketch here in line, I can always just right click on it and edit it. And to get back into it, I'm going to start drawing over here to the left. So I'll start a line. I'm going to make myself coincident with the top quadrant here of the circle. So this is going to be 90 degrees. I'm going to click on that top quadrant, and I'm going to draw a horizontal line over here to the left. So I know that that value has to be somewhere over here, and I'm going to click once, and I'm going to drop that point. Now I could always hit escape and then jump into my tangent arc to start dealing with those other arcs that I was talking about, because we have to do an arc to another arc to another arc. But I can also force my line tool to turn into tangent arcs by doing this one simple trick. And that is, if I was going to move off this line, I have just solid straight lines. But if I trace over this line, I'm not clicking on anything yet, I'm just moving my mouse over it. And then I'm going to move my mouse in an arcing fashion past that next point. It's actually going to force that straight line to turn into a tangent arc. So if you look at my mouse here, I'm just going to move my mouse over, and then I'm going to start arcing it down, and hey, look, it's actually creating a tangent arc from that other line. And I'm going to just create some geometry here. I know that this has to turn into another smaller arc, so what I'm going to do is I'm going to drop this here, leave enough room to make that smaller arc. and then it's going to default again back to that straight line. So I'm just going to have to continue to repeat that simple trick. So I have to go over this arc or over this line, and I'm going to force some tangency. So again, I'm going to leave enough room to create another arc that's going to go tangent this way. So don't leave it short. Kind of go even here. And then again, we have another defaulting straight line. So I'm going to have to go over this line here. I'm going to position this, so create this arc like that. And I'm going to leave it there. And I'm just going to pull a straight line over here. So one thing though that I want to make mention of is that since this is not in line with the center point of the arc that we just created, I'll eventually have to come back and make these two entities tangent. But that's fine, it's not a big deal. I'm just going to end that there. I'm going to come back over. I'm going to create another arc here. And then I'll create another arc by coming over this line. And then this one, I kind of want to leave, I don't want to go all the way over here. I want to leave kind of in the middle somewhere. And then I'm going to make another arc like this. I might run into the same issue that I was talking about with tangency, where I'm going to have to create this line. And I want us to either be above the quadrant over here or below it. So go ahead and mark a line here. Don't get this like projection line that's in line with the quadrant, either above or below, and then we'll come across and we'll intersect with that circle there. Now this isn't very pretty. All we're doing is we're trying to establish some geometry that will eventually come back and smart dimension to, so we don't have to draw a line, smart dimension, draw a line, smart dimension, draw a line, smart dimension. It's going to take way too much time. I always try to create a profile of all the geometry that I have and then go ahead and smart dimension everything all at once. So let's go ahead and start smart dimensioning this. I can also turn on my reference sketch if I wanted to get that geometry. So for instance, if I didn't have a blueprint to reference, I could go ahead and turn this on, and I could go into my evaluate tab, take the measure, and I can get this distance to this distance, and that's telling me that it's 0.156. If I wanted to, I could always click on this, control copy, and then go into sketches, smart dimension. I can get that line to that line, and then I can make that 0.156. Or I can just type it in, 0.156, whatever I want. Same thing, I can go into evaluate, evaluate measure, and I can get this flat to this top edge, 0.2812. I can click on that, control copy, or I can go into my blueprint and I can see that that value is 0.2182. All right, go back and do sketches, smart dimension, grab that flat to that edge, and then I'll make that 0.28125. Okay, so now I'm going to start establishing some radii. So what I'll have to do is I will have to see what this value is. In the evaluate tab, measure, I have a radius of 0.4375. Go ahead and smart dimension that. Make that 0.4375. Looking pretty good. The next arc in line is going to be 0.03125. You can also see here on the blueprint, I have a value of 0.031. So I can make that 0.03125. And I'm just going to the full fractional values here. The next arc that I have is going to be evaluate, measure, grab that, 0.375. And this is that one that isn't fully tangent. I'll actually have to establish tangency here in just a second. But if I go into the smart dimension tool, I can make this 0.375. And then I can also force tangency here by holding down the control key, clicking on this arc, and then while still holding down the control key, clicking on this flat, and then making or forcing a tangency with add relations. Now, if I want my dimensions to kind of line up a little bit better, or my geometry line up a little bit better, I can grab this center point here and kind of move this into place. if I want it to just look a little bit prettier. And I can continue on with dimensioning. So if I want to look at the evaluate measure, I can get this value here, 0.125, smart dimension, 0.125. And I do want to make mention of this on the blueprint as well, because if I look here on the blueprint, I have a value of R125 in 2 places, and the only other location that isn't dimensioned here on the print is this arc here, so we know that that is 0.125. Okay, so then we have another arc, which this kind of got a little bit twisted up. I'll have to pull this back like this, okay? And I'm going to take a evaluate measure, and I'm going to measure that value there. I have a value of 0.015625, so I'll make that value 0.015625. And then again, I have a value here of 0.28125, 0.28125. And then I have to establish an angle here, so I might have to reposition this a little bit. So if I take this point here, I just pull that back on itself, and I go smart dimension from that flat to this angle, I can give a value of 45 degrees. So I'm in a pretty good shape. Everything is looking relatively good. If I turn off my reference sketch here, I have something that kind of resembles a bottle opener. But I see 2 issues. One issue is that this area is separate from this area because I see that this is watertight, it's fully enclosed, it's blue, but I want to see everything out here fully blue. And then I also want to put in my 2 sketch fillets here. So I'm going to have to break this up by using the trim entities. So if I go over here to trim entities and I use the power trim command, I can slash through this and the rest of the model is going to be watertight. Now if I just had it like this and I went to go extrude it, it would try to default just as that circle as the extrusion. But if I go to trim entities and I trim that and I make this all one contour, that's going to extrude as one now too. So I have the ability to go ahead and add sketch fillets to these 2 corners or these 2 intersections. So in here in the sketch tab, I can click on sketch fillet. This is very similar to the 3D fillet command, but what I can do is I can either choose 2 lines or I can choose 1 intersection point. So I know from my, and I'm just going to reference the blueprint on this one, I have a 1/2 inch fillet there, and then I have a 1/8 inch fillet right there. So what I'll do is I'll just select on that intersection point and I'll type in the value of 0.5. That's going to establish that tangent arc between that line and that line. And then once again, I'm going to just change the value here to 0.125 and grab that corner right there and hit the green check mark. So this is convenient because this value is fully defined because it was just based off of this dimension and then this dimension. But this one is unbound because we haven't established the value of the center mark of this radius. So we're going to go ahead and do a couple different dimensions, and they're going to be right here on the print. We're going to start off by doing this 0.953, then do the 1.781, and then do the 1.953 from the center mark of the through hole. So what I'll do is I have to find the center mark of this arc that I just created, of that 1/2 inch arc. And I can find that by either hovering over it, and you'll see that it'll turn orange down here when I hover over it. And then I'll use the smart dimension, and I'm going to grab that point right there to that dimension right there. And that value is 0.953125. Okay, and then the next one that I'm going to get is the 1.781, which is going to be off of that 1/8 arc in there. So I'm going to click on this point right there, or if I wanted to, I could hover over it and I could establish that that is the center mark of that arc. I'll dimension off the center of that diameter there, 1.781. 3.8125. And then I'll also get that 375. And I'll look here. Oops. Look here. 1.953. And the full fractional value of that is 1.953125. So if I hover over this arc here, I should find that center mark, grab that point, 1.953125. Okay, so things are looking pretty good. If I wanted to, I could turn on my reference sketch and show it. I'm pretty close, but I have a couple underdefined areas. And what I'm seeing is that I don't have the full extent here, or I don't have the full extent here. And what I'll have to do is I'm going to have to actually establish a pretty tricky dimension for us. And we're going to do it in the same way that we just did all these center mark to center mark. And then we're going to fake it out and then use the properties bar to go, or properties command to do max to max. So what I'm going to do is I'm going to dimension this arc to that this arc here, and then place that dimension and then change it. So go ahead and start up the Smart Dimension tab tool again. While doing this command, you never want to go from a center mark to a center mark. What you want to do is you're actually going to grab the arc to arc. And then you're going to pull the dimension up, and then you're going to fake it out by just hitting the green check mark. And now that fully defined that edge to edge, but we want to actually get the max extents. So what I need to do is, as this is selected, I can go over here to leaders. If this isn't selected and you don't see that this dimension is light blue, say it's just like black like this, I can do this with any dimension that's arc to arc. I can click on it, I can go into leaders on the left-hand side, and I can choose my arc condition. So from first arc condition to second arc condition, I can go max to max, and I can establish a value of 2.5625. And then I can do the same thing by doing from the length, I can do to the width. So I can do this arc edge to this top edge here, and I'm going to fake this out by placing that dimension, hit the green check mark, and I'm going to go leaders max, and I can type 0.5625. And if I hit the green check mark and I turn on my reference sketch underneath it, take a look at that. I'm right on top of that DXF, and I've fully dimensioned and I've fully defined all the geometry that I need. So if I ever get a revision change from the shop floor that, hey, this width needs to change, say it needs to go from 0.15625 to 0.25. Well, now I can make that change and everything is tangent to itself. Or if I have to change this radius here from 0.125 to 0.25, it's going to update accordingly, and none of my geometry is going to be negatively affected from it. Now, there's a whole thought process behind dimensioning from center points of arcs to actual intersection points. I think intersection points are a little bit more helpful because, for example, if I had to change this value here, this ½ inch, well, it's actually going to move all the geometry over to the left of it. If I actually deleted this dimension and established a intersection point, and I gave that value there, and I changed this 0.5, well, it's actually never going to affect the geometry to the left of it. It's just going to affect that arc. But that's a little bit more advanced. We'll cover that in future exercises. The way that this was dimensioned as is perfectly fine. I just wanted to point that out in case you ever had to make any revision changes that had to do with radiuses or arcs like that. So that said, I'm in a pretty good spot. I'm going to hide my sketch underneath, and I'm going to go ahead and extrude this out the distance that is shown on the print. So I'm seeing that it should be 0.46 thick. So I'm going to go ahead and go to Features, Extrude Boss Base, and type in 0.46, and I'm going to extrude it out like that. I now have to add a through hole, and then I have to do a couple edge breaks. So if I start a sketch here on this face, start a sketch, I can wake up the center point of this arc here by simply selecting the circle tool and then hovering over this arc edge, and it'll wake that center point of the arc up. Draw a circle out, smart dimension that. I know that that value should be 0.213. If I didn't know that value, I could always turn on my reference sketch and then I could take a measurement. And then also one thing that I'm seeing here, all these internal edges here are just the chamfer lines. So we can reference that if we wanted to find the chamfers, but they're listed here on the print as well. So features, extrude boss base, not extrude boss base, extrude cut. My apologies, this is a through cut. And we know that from the blueprint because it says 0.213 through. So we'll go ahead and change this to through all, hit the green check mark, and then we're going to continue on by using the chamfer tool. So instead of the fillet here in features, we'll go and hit the drop down and we'll use chamfer. And we'll choose to create a 1/32 chamfer, 45 degrees on that edge. And then the 1/64 45 degree is typical, which means it's at all other edges unless listed otherwise. So typical is just that, again, all other edges unless listed otherwise. So we're going to have that apply to all these other edges on both sides. So that said, we're going to head and just type in, if we don't know the value for 1/32, we can type in 1 divided by 32. It's going to come up as 0.03125. Grab that edge, and then we'll grab that edge of the hole, hit the green check mark, and then again we'll go and do chamfer. And then we'll do, in this instance, it says 1/64. So then we're going to type in 1 divided by 64, and then I can choose to grab that whole tangent edge. And we know that all this is tangent because we're using this tangent propagation. If I just want to do like one edge, I could turn that tangent propagation off. Not very helpful in this instance, but just an option for us to know. And then I'm going to grab the other side as well, and then hit the green check mark. And that should create a nice solid model. I'm going to check it against my reference sketch, and everything seems to be lining up exactly with the DXF, completely independent of the DXF. So I'm going to end this video here, and then we're going to start on the next video by creating different configurations and applying materials to those configurations to be set up for a finite element analysis.